Let's see what is a capacitor. A capacitor is a device that can store charge. It consists of two conductors placed near one another, separated by vacuum, air, or any other insulator, known as a dielectric. Usually the conductors are in the form of parallel plates, and the capacitor is known as a parallel plate capacitor. When the plates of such a capacitor are connected to a battery of voltage V, it establishes a potential difference of V volts between two plates, and the battery places a charge plus Q on the plate connected with its positive terminal and a charge minus Q on the other plate connected to its negative terminal. Let the Q be the magnitude of the charge on either of the plates, and it's found that Q is directly proportional to V, or Q is equals to CV, where C is equals to Q upon V. The proportionality constant C is the capacitance of the capacitor, as we shall later see that it depends upon the geometry of plates and the medium between them. It is the measure of ability of capacitor to store charge. Capacitance of a capacitor can be defined as the amount of charge on the one plate necessary to raise the potential of that plate by 1 volt with respect to the other. The SI unit of capacitance is coulomb per volt, which because of its frequent use is commonly called farad, after the famous English scientist Faraday. The capacitance of a capacitor is 1 farad if a charge of 1 coulomb given to one of the plates of a parallel plate capacitor produces a potential difference of 1 volt between them. 1 farad is an enormous amount of capacitance. For practical purposes, its sub-multiple units are used, which are 1 microfarad, 10 raised to minus 6 farad, 1 picofarad, which is 10 raised to minus 12 farad.